So we will talk about VPC peering, the very basic stuff, and then we will talk about transit gateway. So question comes, why somebody would have different VPC? That is first question. We always need to understand why of a technology, not how to implement and what it is. But question comes, why a business or someone would actually be utilizing a VPC peering? What is the need to create multiple VPC? What is the benefit of doing that? Anyone? Why we would create multiple VPC? Why somebody would have multiple VPCs created? What is the benefit of using that type of multi architecture? Why I would manage multiple of them? To share resources, that is one of them. Exactly, that is true. What else? Let these questions answers coming up, and don't be afraid to say I don't know. That is still okay. At least you are participating. So even if you don't know, but then I don't know, nobody's judging you. Separate network. Good practice to have environmental wise segregation. Multi-region, yes, that is another region. That's true. To have resources in different region, true. Not to travel through internet. In a way, yes. In a way, yes. But there are other ways also of not to travel to internet. Segregation of environment like prod. So yes, I agree that most of the time we may want to have a segregation, like it is mentioned here by Shiva DevOps, that segregation to have resources in different region. I agree that is also another one. Then we have Raghavendra showing up network segmentation. VPC can be used to segment your network into smaller one manageable part that can also help to simplify network management and reduce the risk of network consumption. That is a good one. Yeah, thank you. So yeah, these are all the things like segregation we are utilizing, multi-region if we want to go, we would utilize VPC peering. So sometime it may also happen, like I have not seen that answer here, accounts. There may be different accounts altogether, right? So maybe I am a service provider. I want others to connect to my VPC and access some services from there. And that's why I may want to share my VPC. Not the best practice, but it is still a thought in case you have some specific customers to talk to or a specific resources to share. You could go ahead with that. So account segregation is also one of them. So we will keep on expanding that knowledge. Now, hopefully everyone remembers this picture. We are building this network piece by piece. We talked about basic stuff like network ACL, subnet, internet connectivity, DirectX, and now we are focusing on region to region VPC peering. It could be intra-region, it could be within region, doesn't matter. It could be across account, it could be within the same account. So VPC peering is a logical connection we create, and we call it in a interface something called PCX, and then some random number associated with that. So whenever you hear a PCX, that is a peering connection which is being created, and that peering connection would be allowing me to communicate from one VPC to another VPC, leveraging Amazon's global network, not sending traffic to internet, and that's how I would be able to communicate to this. And then if it is a VPC, those resources of security like network ACL, security group, they would still apply. They are not going away. They would still be maintaining the security the way I want to configure. So that is on a high level what VPC peering is. Let's go ahead and quickly create a VPC peer between two VPCs, and we'll see how these things will be working. Right. So I'll quickly go into console. It is this service is basically much explained better when I go to console. So I'm going into console, and we would be selecting some VPCs to peer to, and we will then use a better way of sharing these resources through transit gateway. So I'll talk also about that. So if I have to share VPC, I need to have VPC at least, right? Question to you. Do I need to have a VPC with subnet to create a VPC sharing? If anyone has thought about it, if I have a VPC without any subnet in that, would I be able to create VPC share or not? What do you think? I do not have a subnet in the VPC. Can I still share VPC? Anyone? Answer is no. Okay. Let me explain that. Let me explain that. We will see that in a minute. So, all right. So let's go ahead and create a VPC here. And just for sake of it, so let's call it, wow, this is the name auto generation. Was not aware. This is the new thing, but I am now creating. This is, let's call it my VPC01. That's not very creative name, but yeah, still serves the purpose. And then I would be putting it into 10 series IP address. So 10.0.0/16 is the IP address I'm saying, and I'm not creating anything else beyond it. This is in Oregon region. I created my VPC01. That VPC is ready, and now I'm going ahead and creating Maybe another VPC is there. Let me just delete that one because I cannot edit CIDR just once it is created. So that one VPC was also there. Let me just delete it, and we would create my VPC02 in a different manner. Maybe there is a security group associated. So let's right now just type ignore it, and then we will keep moving forward. So we will go ahead and create another VPC here. That is my VPC02, and I am using 172.16.00/16 as a network. Now, why I bought that question of subnet? Because VPC peering is not associated with a subnet. Yes, so yeah, so VPC peering and VPC creation, like Sunandam has a question, is it possible to create a VPC without subnet? Possible is, you can, but will that be useful for a lot of things? Answer is no. It's like having a house and having no walls in that. It is just like a plain hall. So you could still call it a house, it's still a VPC, but not very useful. So still possible, but not something to use for a regular purpose. So I have created VPC now. VPC peering doesn't work on a subnet level. It works on a VPC level. So I could still have these VPCs peered without having anything on a subnet level created. Right. So these VPCs exist. And now my intention is to create a peering connection between them. Very simple logic. I would go ahead and search for my peering connection here somewhere. This is my peering connection. And I would go ahead and say I want to create a peer connection. Okay. So let me call it VPC 0102 peer, right? I would be saying select local VPC to peer with. So it is a two-way process. You have to select local VPC and a remote VPC. Now there is no concept of source and destination here. It's not a one-way traffic. It is a two-way traffic. So they both parties involved in the same manner. They both have to agree to this routing table rule and other stuff, and then only communication would be happening. So I say this is my VPC01. That why I want to connect to. It detected its IP address, and see this. I could have connected to my account or another account. In that case, I have to select my account ID, and I have to then provide the VPC ID also of that particular VPC. Right now, I am interested only into my account, and this region, I have these VPCs available. I would be connecting it to my VPC. So it was able to identify the associated subnet with that, and then I can give this particular VPC to peer a name, which I have given, and then I could just say create peering. So that's what we are trying to do here. We have just created a VPC peering connection, but consider that this is a physical connection as of now. And then if you look at it, it says pending acceptance. So I initiated a peer, and then someone at the other end of the peer has to accept it. You can't just randomly go and connect to anyone. You have to get their acceptance, then only your communication would be allowed. Now I am in the same account, so that's why I could go ahead and just accept this peering. But in real world, it would be some other account or maybe some other admin who would be actually allowing you, would be accepting the peering connection. So I have my peering connections here. This is my peering connection, as you could see, and it shows into a pending acceptance state. As it is my own account and I am the owner of this, I could go ahead and say accept request. But before that, it is always better to check who is requesting, and then when it was created, I don't want to peer with some unknown VPC. It is big security risk. So I have created here a VPC peering, which is for this PCX connection. This was the requester ID and some more details on that, and I could see from where it happened. It could have been across also, and then we could go ahead and add routing table also already. So we'll talk about routing table in a minute. But I saw this request, and if I'm happy, I would say I want to accept this particular request, and then my acceptation is done now. All right, good. So this peering connection is ready. Now, is it sending traffic? Anyone? If I have this peering connection right now, can I start sending traffic using it? Like if I have a machine here into, so we created this architecture so far. And my question to you is, can machines in 172 send request into 10.0.16? Raghavendra is saying no, we need route. Exactly. Yes, so we need to have a route table associated with that. We route table would allow me to send traffic. I call route table as a Google map. So maybe a new city has opened up or a new airport has opened up. I won't be able to reach out till Google Map has entry for that because I don't remember every path. So what we need to do, we need to add routing table entry on this case. So let me go ahead and add a routing table entry. In one VPC, I would add entry for routing table on the other side. So I would point my request from 172.13 to 10.0.16 on to the PCX, and PCX would take care of all the things for me. So that's what I'm trying to do. I would go to my route tables and I would be selecting a specific route table associated with my VPC, which is my VPC 01. Let's go ahead and check that. I'm adding this into default route table, but you could have added it into other route tables also. Let me quickly check the name of these VPC so it would be easy. I'll note it down on a notepad so that we can refer it again and again. So this is my VPC 01, and then this one is my VPC 02. Just to save time, I have put everything into one single location, but you could have done it on another location. So I am on this VPC 172.16. I have its detail. I know which route table it is associated with this. So this is my route table associated, and I would just go ahead and say, okay, route table, let me add an entry. Currently, it has entry for only local communication, and you can't remove that. What I'm going to do here, I am going to add more route, and this time I'm saying I want to talk to a destination which is 10.0.0.0.16, sorry, 0/16, and that should be forwarded to whom? Anyone? What I should select as a target? Probably you would have guessed that I would select a peering connection. I only have one peer, so it is being displayed here. I have selected that, and now I have clicked on Save Changes. All right, so I have set up this route table entry here. As you could see, this is what I have done. Now my question again. I have a machine here, and I have a machine here. Can they communicate right now? I have peering entry. Can they communicate? We need to add a route from both the region pointing to the subnet of the other region, not the subnet. Pralay, we are not pointing to subnet. We are just pointing to PCX, and PCX would decide how to forward the traffic. Now, the VPC which I created, they do not have IGW at all, no gateway. So they can't communicate because TCP, let's say I go ahead and say ping. So ping is a two-way traffic. My requests need to know a path to go from here to here, and these machines here should have a path to respond back to me, right? So that person who sent request knows how to reach to 10.0.0.16, but the person in 10.0.0.16 doesn't know how to talk back to 172. So what I would need here, I would need a routing table entry also here. Then only this communication would happen. Otherwise, it won't happen. So next thing I have to do is create a peering table connection here into this. So yes, we need a reverse path exactly. The routing table is not smart enough. It has to define both the paths associated. So that was the first route table I have associated, and I would go to my VPC 02 and sorry VPC 01, and in its route table I would add entry for other location. So let's go ahead. This is 10.0.0.16. I would go to its route table here, and I would now add entries for my routing communication, and that will be a simple entry by editing a route, and this time I would try to talk to 172.16.00/16, right? And that will be what my target would be. My target would be again a peering connection which we have just selected, and now I have taken care of peering, right? So what I did here, I have made changes into the default route table. Is PCX a VPC endpoint? Answer for that is no. No, PCX is not an endpoint. It has a some routing table entry, so it works little differently. It behaves like an endpoint, but it is not, because endpoint, again, this is a little longer discussion here, Francis. So it is like endpoint are two. One is gateway, which requires a route table entry, so it sounds similar to that, and another one is your interface. So it is not interface at all, because interface requires you to have a subnet, and in that subnet it would create a network interface. So that is not at all something which we have here. Or can you have default route to that VPC? Default route, not directly. Let me show that. That is a different way of doing it, but the question has come, as it is coming from Hari Krishna, that can you have a default route to that VPC? Not directly, but there is a way of doing it. So see this. I am saying my 10.0.0.16 is local, but here I could have used these. So I could forward my local request to an instance which I am acting as a proxy, or a network interface which could be leading me to somewhere else, or to a gateway load balancer, or just I am keeping it local. So there are ways of doing it. We will talk about that when we discuss about a network firewall. So you should be able to create this kind of logic. Plus you should be able to also have transit gateway coming into picture. So we can create those stuff, but not right now. That will be a little too much for today. All right. So hope this thing is clear. And we have now peering connections set up, and we should be able to send our traffic across both of them. So they're very simple, not a complicated thing. And hopefully you have a better idea on what we are doing. Is peering is not two-way. It is two-way, Babita. So you need to still set up route. So see, peering is two-way because I had to initiate peering and somebody has to accept the peering. So yes, it was a two-way communication, but the path is physically there. But if I'm not making my route table aware, then it path is of no use to me at all. So yes, we have between VPC, and we will need to communicate to them through routing table. So routing table would still always be required in that case. So VPC peering is established into one-to-one fashion. I would have one VPC connect to another VPC. So this is my A, this is my B, and I have to establish a peering connection. This is how a peering connection looks like. So that's what VPC peering is actually allowing me to do, right? Next thing, you could set up cross region, cross account peering, no problem at all. That completely works. You should be able to provide those kind of security. And then two-step process, request peering connection and accept peering connection. We just saw that. So that is possible. We could have utilized that. And route table entries direct the traffic. All the mechanism of forwarding is done by route tables. Plus peering connection use private IP addresses. Traffic always stays on AWS global backbone. So we would be automatically identifying the IP address range, which is private, and will forward traffic always going through that. So that's how you would utilize that thing, right? Now, okay, last topic question here. There is no charge to create VPC peering connection, but there is a charge for data transfer across peering connection. So when I create a peering connection, no problem at all. But when I'm trying to have a traffic sent over it, I would be paying the data transfer charges on that. So just be aware about that particular thing, right? Uh, for path for each of this subnet. I won't say subnet Hari Krishna here because I may not want to talk to one subnet. I may put a path of the whole VPC IP address range. So if you remember this route which I have created here, I'm not pointing to a subnet here. I am pointing to the whole VPC range. So anything now here, if this VPC has subnet 1 or 2 or 3, whoever is in this range will be able to contact. Still your security group comes into picture, still your network ACL comes into picture. So you should still be able to access those things. Shouldn't be a problem at all. So I hope this thing is clear and you have a better idea on that. What will happen if both VPCs are in sharing same subnet? Good question. We won't be able to communicate across them. So one requirement for a VPC peer is that not to have overlapping IP address. So overlapping IP addresses will not work. They should not have overlapping IP address, because if you are using the same IP address, this one is using same IP address. Now how route table will differentiate which traffic to send to whom? So this will not work in this particular case, but there is a workaround for that particular thing, Hari Prasad. That is called a transit gateway. And through transit gateway, even if you could create a solution where your VPCs, even with the same subnet IDs, sorry, same IP address range, would be able to communicate, but it is a solution, not a default setting. So you have to set up that solution by creating a transit gateway and then configuring route table and configuring NAT gateway associated, but technically possible. Official answer, if you get a question in exam, two VPCs with the same IP address, I would say it is not possible. We can't pair those two VPCs, right? So there would be some checks performed before we end. Can we create routing without peering uh, connection acceptance? I haven't tried that, Hamel. So I'm not 100% sure. If I have not accepted that, can I create it? Let's go ahead and quickly check it. Nothing wrong in just verifying something. So let me try to create a peering connection first, and then we'll see if we can connect to it. So I am into my peering connection. Let me create a peering connection here. Let's call it test peer, and this time I want to connect from, let's say, my VPC 01, and I want to connect into another region. Let's select if we have something into Northern Virginia. And if I have something in Northern Virginia, I should be able to get connection to that also. So let's go ahead and quickly try that. If without acceptance also, can I create peering connection or not? So I would still be able to probably create, but it won't accept any traffic because it is not into acceptance phase. But let's quickly check that. Good question. I haven't thought about that scenario, but let's try that. Okay, so let me go to Northern Virginia. Probably I have some various range of VPCs created there. I would try to connect to any one of them. Just I need to get the VPC ID associated. So I have 5 VPCs here. By default, you can have up to 5 VPC. If you're going beyond it, it won't allow you. So just be aware about that also. So let's say I want to connect to this VPC-C, which is having this particular IP address 10.3.0.0.16, and I am trying to connect to Northern Virginia VPC, and I said create a peering connection. So I have created a peering connection. It is initializing request to done. That is all good. Peer request has been requested, but it is not into the acceptance state. And let me go ahead and now pending acceptance test peer, and I would try to create a route table entry for this. So let me go ahead to VPC 01 and try to create a route table here entry, sorry, route table entry here, and we'll see if we can create those specific settings or not. So screen area is very small. I have this route table. These are my routes. I would go ahead and say edit route, add route to 10.3.0.0/16, and let's see if we can get a peering connection. Yeah, I can still have route table entry added. I can still add it, but obviously it won't be actually sending any traffic because it is not into active state. See this? So it will still be physically route present, but it would be into black hole state. Black hole is like, as the name in the physics is black hole, which is not allowing anything to be coming out of it. It sucks everything. Same thing. So you would be able to send packet, but you will not be accepting any request response coming from that. So technically you can create entry, but it would be pointing to black hole. Right. Good, nice. Let's move forward then. Now, so that is clear. That is not a complicated topic. Probably most of you know about it. And let's now talk about transit gateway. So let's go ahead and talk about what is transit gateway and how it works. And I can't explain things without analogy. So let me go ahead and explain it thing through an analogy so you would understand it better. Right. Hopefully everyone can see the drawing I'm going to make. Right. So let's go ahead and talk about it. Now, let's say I am living into UK, right? In UK, there are different cities. There is London, there is Leeds, there is Manchester, there is Cardiff, and then other cities, right? And let's say I have to fly from these cities to somewhere in India, right? In India, let's say cities are New Delhi, and then we have Mumbai, then we have Bangalore, and yeah, people will hate me for not calling it Bangalore, and then we have Chennai. And there would be tier 2 cities, like I belong to a city called Indore. So that is a city. Now, if I have to go from, let's say, Leeds to Indore, that is not a direct flight. What I have to do, I have to come from Leeds to London Heathrow. Even Manchester may not have direct flight, even Cardiff may not have direct flight, because that would be very complicated for airline to maintain one-to-one connectivity to every city in the world. That is kind of impossible, and they may not have that much of traffic coming into it. So what these airline companies do, they operate into a hub and spoke design. For British Airways, London Heathrow is the hub. All the people or passenger from wherever they are, even from different countries, they would be flushed, they would be brought into London Heathrow, and from there you would be able to get into the next location of it. And again, if London Heathrow is trying to fly, they won't be directly flying to Indore. Maybe they would be flying to the again a hub in that country like Mumbai or New Delhi, and then I have to take another flight to reach to my place. You get the point? So this is a hub and spoke design. And if you look at any airline, they all have their hub, right? British Airways, the hub is London Heathrow. Air India, Mumbai and Delhi are a hub. Emirates, there is a hub into Dubai for that. If you're talking about Lufthansa, their hub is into Berlin. So every airline has their hub. They get all the passengers into hub, and from that hub they start the flight, right? So that's how your actual logic works. Why? Because it is efficient. I don't want to keep on creating that many flights, which will be really, really complicated to maintain, operate, and it will not be economically viable. So that is the concept of transit gateway also. Nothing complicated, exact same concept. Let me explain that thing now. So if I have a VPC here, A, B, C, D, E, they have to all talk to each other. A, B, C, D, E. One option for me is I could go ahead and create a peering from here and here, then another peering from here to here, right? And then one more peering connection between them, another peering connection between them, and then these peering connections. You could clearly see how many peering connections I have to keep on maintaining. And this is only 5. If I add one more VPC now, I have to again reestablish all these peers. So this is not at all a scalable design. So what we can do in this particular case? In this particular case, we could take help of transit gateway. So what we will do, we will deploy a central piece into this puzzle, which is my hub, and that hub would allow me to communicate to various aspects of my communication. So this is my transit gateway, or we call it TGW. And through this TGW, we could create a communication channel, like it is allowing A to communicate, B, C, D, all of these will communicate to transit gateway. That's what we are trying to do here. So transit gateway is a hub for your request, and all the VPC who are connecting to it, it is my spoke. I hope this thing is clear. Now, one thing to be aware, this transit gateway is a regional entity. It exists into a region of your choice. Like I said, in UK, the regional hub for British Airways is London Heathrow. Same thing here. Transit gateway exists within a specific region, and then you would keep on adding more VPCs to it. Now, if let's say I'm going back to my airline analogy, if it is London Heathrow, if it is considered, now people will not always come to Heathrow by flight, right? Some cities which are nearby, which are not having that many of, let's say you are into Cambridge or you are into Oxford or or other cities, you may just take a train and come to it. Same way, this is not only for connecting your VPCs. What you could also do, if you have other type of connections also. What I mean by other type of connection, if you have a direct connection, or if you have a VPN connection, they can also be coming and connecting to this particular transit gateway. And now you could see this has become like a central place where everyone is coming and everyone is able to communicate using it. So that's what we mean by a transit gateway. We can keep on adding more and more resources, and we can have up to 5,000 VPCs connected, and that would ensure that we are able to provide as much as the traffic coming from central place. I hope everyone is following along now. So this was the right picture till few years back. Now AWS thought that okay, so London Heathrow has to be connected to another hub. Let's say Amsterdam Schiphol Airport is another hub into Europe where a lot of traffic happens. Or if I'm talking about US, maybe JFK is the another airport where a lot of traffic happens. So JFK is happening, or let's talk about Delhi. So that's if I'm talking about New Delhi here. New Delhi is again having lot of traffic coming from different cities in the India, and the same concept of having people arriving here by bus or train or something also exist, but this one is in a different region altogether. So what we support now, we now support transit gateway peering also. You could create a peering connection between them also. So this is called my transit gateway peering. So this peering will allow me to communicate across transit gateways also, and I can now create a flight. Let's say I'm coming from A, I would come to transit gateway, and then I will be going to New Delhi, and from New Delhi I would be going to somewhere else. So that is how I would be able to go ahead and utilize all the component and create a whole scale network so that all type of communication can happen and we can communicate across different type of network. I hope everyone is following along and for understanding the basic look idea. Any questions so far? Anyone which is not clear? Anything which is not clear, let me know. So that is your transit gateway, right? And that transit gateway would allow you to perform all the communication like the way you want. Now, in default condition, when I create a transit gateway, I'm talking about default. In default condition, everyone is allowed to talk to everyone. That is a default condition. But obviously you do not want it. You may want to keep a specific stuff available only to specific location or a specific resources. So let's say this is my dev VPC. I want only to talk to QA, and this is my prod VPC. I may want it to talk to only pre-prod. So what transit gateway allows you? Transit gateway allows you to create multiple routing table and create association. So this routing table would have entry for very specific route or very specific traffic. So only those specific traffic will be allowed or denied. That is how you could control who can talk to whom. So that is what a transit gateway is actually doing. And this type of design can help you in some other concept. So let me utilize another option. Let's see what we can do. All right, so I'll talk about that. Question from Kurt is about VPC peering is regional, transit gateways cross regional. No, answer is wrong on that call. So peering can be across region, within region. Transit gateway itself, when created, is within region, nothing beyond it. Transit gateway won't go beyond a region. If you want, you have to create another transit gateway in another region and then create something called transit gateway peering. So transit gateway is a regional entity. Transit gateway peering, it can now, I believe, happen within the region also. I'm not 100% sure. Anyone, Michelle, Prasad, if you could check that if a transit gateway peering is, I believe, is now supported within the region also, but I may be wrong. I may be dreaming. So just check that and let me know if that is possibility. Let others know if transit gateway peering can happen within the uh, region. I doubt it, but let's check. Okay, so this is my transit gateway peering. I hope analogy is clear and you have a idea on this. So that is what we are doing. We are getting everyone from Edinburgh, Newcastle, Leeds to Heathrow, and then we are bringing them to Delhi, and then other cities would be connecting to that. So we would utilize that. So that's what can happen. Question from Pawan. In this hub and spoke model, do we still need to have routing table entry for A and B? So routing table for A will have entry for VPN, not on those locations. So Pawan, what it will be happening, I'll explain that thing to you now. That was my next point I wanted to discuss about. So what we would do in this particular case is, so let's say this is my three VPCs. And this is a direct connect and this is a VPN. So this is my direct connect. This is my VPN connection. This is my VPC A, VPC B, and VPC C. And this is my transit gateway here. What we would do, we would say transit gateway should become the next point of contact for everything. Now, this is a good design. With transit gateway, what I could do, I could also have connected something called a shared VPC. This is a good design which you could follow in your environment. Now, on the shared VPC, I have done all these connectivity, like my IGW is connected to this shared VPC, not directly to any other VPC. So these VPC A, B, C, they do not have IGW. What they have always sending their traffic. So I would add their training routing table entry. And let's say this is in 10 series. So it will have an entry which will be in the routing table 10.0.0.0/16, and that would be pointing to local. And then I would have an entry 0.0.0.0/0 that should go to transit gateway. So what is happening here? Anything which is not matching to the local, that will be going to TGW, and this similar entry of everyone forwarding traffic to TGW would be there. So TGW would refer all traffic, it will get all the things, and then we should be able to have a component connected which will allow traffic to be forwarded. So I would say, okay, B, you want to go to internet, no problem. You just send traffic to transit gateway and let it decide how to forward traffic further. So that transit gateway would allow traffic to communicate, and then you can create routing table entries in a way that you could say, hey, I want A and B to communicate, no problem at all on that. So A would send traffic to TGW, then it will forward to B, so they would communicate, but I don't want A and direct connect to have any communication at all. So direct connect is also coming to transit gateway, but we could create again here a black hole route which will block traffic to go from A to DX. So that's how we would be creating routing table entries and communication. So idea I'm trying to convey here is that most of the time you would have a shared VPC with transit gateway, and all your common services, let's say Active Directory or your Exchange servers or your antivirus services, they would all be running into shared VPC. Even IGW is connected here. So all the traffic which has to go out, they would all be forwarded by transit gateway here. Everyone communicates, and then all filtering and all shared services are in one place, and then I could utilize my IGW to get connected. So I hope this thing is clear and you have a better idea on how all these things work together. So that is called my transit gateway. Okay. All right, good. Another example I take for transit gateway is transit flight, right? So let's say if you have to go from, let's say you are in Bali in Indonesia, I have taken that flight and that's why I can relate it. And I had to go to New York. There was obviously no flight from Bali to New York. What I had to do at that time, I had to go from Bali to Singapore. From Singapore, I was able to get a flight to Amsterdam, and then from Amsterdam, I was able to get a flight to New York. The good idea is we are utilizing Amsterdam or Singapore as a transit point. And from transit point like Singapore, you would have flight to different parts of the world, not just Amsterdam. And same way, Amsterdam would also have flight to different parts. So transit gateway is basically allowing you to not talk only to different transit gateway, but it can also allow you to communicate to anything. So once you are here, I came to Singapore, now I want to take a flight for Delhi, or I want to take a flight to Dubai, or I want to go to Kuala Lumpur, I could just go ahead from there. So that would be much easier for me. So transit gateway will become your hub and all your traffic would be forwarded from there. Now, we do not have time, so I can't explain more details, but I'll talk a little bit more on transit gateway. So this is what a design of transit gateway would look like, region one, and then we would be utilizing it. Question from Pawan, when a VPC becomes shared, when you add its entry into routing table. So it is no option which says rightly can share a VPC. Shared VPC is a concept. So it is still same VPC, but shared in the sense that I'm running some services there which we want to share, and for that we created routing table. Right. So that is your shared VPC. Like in your house, there would be one room which is common for everyone, right? For me, my room is there. For my son, he has his room, and then we have a living room which is common for both of us. So that is my shared VPC, but we still have our own VPCs, right? So that's what we can do. And transit gateway would have transit gateway peering also if the need be. So we will go ahead and quickly show how the transit gateway looks like. There are three components for transit gateway. First is to create the transit gateway itself. So I would need to create a transit gateway. That will be same way like you create a VPC. So I'm in Oregon region and I say I want to create a TGW. I would say TGW01 and see the setting. Do you want DNS support? Do you want ECMP, which is equal cost multipathing? Default route table? If I select this, anyone who I connect to should be able to talk to each other, and I can have default route propagation. So I'm not making any changes and I'm just saying, let me create a transit gateway. Once this transit gateway is ready, it takes little time to get created because this is doing a lot of stuff behind the scene. Next thing would be to create something called a transit gateway attachment. So once my transit gateway is ready, I would then say I want to have a transit gateway attachment who should be able to talk to my transit gateway. So I say this should be my VPC01 talking to transit gateway, and I would be waiting for the transit gateway to come up. But here you see to whom I can attach. So the attachment allow you that connectivity string, VPC, VPN, peering, and direct connect also. These are all the different options. VPC we already discussed, VPN already we discussed about. Connect is your direct connect, and peering is when you are trying to connect to a transit gateway in other account. It would still be same process. You would initiate a connection and somebody would accept that connection. If it is a VPC peering, then you have to just provide the name of the VPC and we should be able to communicate to it. And now I would be needing subnet, because what transit gateway is doing, transit gateway is creating a network interface in the choice of the subnet you specify. It is requiring a network interface to be present, and all your traffic will be funneled through that network interface, and subnet would be required. In this case, I can't connect to it because I do not have any subnet here. But if I'm connecting to, let's say, this, I have a subnet and I should have no problem in connecting to that. So that's why transit gateway communication would require a subnet, because it works with a network interface card. And once this attachment has been created, what I would also need there, I would be needing a routing table entry. So this transit gateway is getting ready. Let me explain one more thing. The last topic here is called my transit gateway route table. My default route table has a similar entry like my standard route table. If I go back to this route table, I could see the routes inside, and you could see what are the routes associated on that. So see, these are my routes here, right? So I could create a static route entry here, and I could go ahead and say, okay, what I want to talk to, active a block hole, which attachment will forward the traffic. So three components are required for transit gateway itself. Second is the attachment, and third is the routing table. If you don't want to modify any entry, use a default route table. Otherwise, create your own route table. And here, if you want communication between two entities, you could create that and say, put it into black hole. So I could do that, and I could say, okay, this is going to be black hole. So anything beyond this will not be allowed to go afterwards at all. This is how your transit gateway would be working. So I hope everyone has a better idea on how this thing works. Again, we have limited time, but yeah, I would be happy to answer any follow-up questions you have. What I have included your first one-page summary book. So just check this for Transit Gateway. There are some details on that how it works, when to use it, who manages it. So this would be available into the resource section. It is available in resource section. You can go and grab this one. Okay. Uh, Overcoming IP issues. Yes, I have a link for that, Pawan. I will be happy to forward. Just ping me on LinkedIn. I would be forwarding you. There is a solution created, and it is a GitHub repository I will share with you. So we can do that. Okay. So everyone, thank you. Let's take a 5 minute break, and we will then switch gears, and then we'll talk about databases. I know I've already consumed extra 5 minutes, but hopefully everyone is enjoying. So in next 5 minutes, we will re-energize and then go to the next topic. So enjoy your break. Talk to you in five. Thank you.